Okay, now it is recording.
We can go quickly for the technical information and the analysis process, but
Yes,
we want to focus more on the scientific parts and the results because our doctor told us that the examiner will focus more on the results. Hopefully, you will understand.
okay, inshallah.
Inshallah.
So, so should I start?
Uh, can we wait just for 1 minute? 1 minute, and we will start because Jafar is trying to reach the meeting.
Okay, Jafar gave me too much work.
Thanks a lot, brother.
Yeah,
We're grateful for this.
and I am also very grateful to you guys as well.
Thank you. You know, we have dealt with many people before, but they
Yeah,
always late. They do not do the exact work. So that's why we are sticking with you with all our
yeah.
assignments.
Thank you.
You are welcome. Can we start now?
Yes,
I think they will join as soon as possible.
Muhammad Akram also joined. Okay, so brother, first of all, after making the 3D model in SolidWorks, we save the model as a step file or IGES file. These are the formats in which we save the file, the SolidWorks model, in order to import that in ANSYS, right?
Yes.
Okay. So after importing the 3D model in ANSYS, my first step is the mesh. So in order to do the mesh, I open the ANSYS workbench, the Fluent, where is ANSYS Fluent? Here it is. I drag and drop here to create this, right? And I
Mhm.
click on mesh to edit. So this window will open, right? So what is mesh? So basically mesh is we divide the structure in very small portions in order to
Yes.
apply the calculations on those small portions so that we can get our results. So there are different kinds of mesh. So in the mesh, I right click, insert method, and I choose tetrahedron method. The reason why I choose this method because in order to capture the curves of the geometry,
Mhm.
this is the best mesh to be selected. So I selected this mesh. And what is the size of each element? The size of each element was 50 mm, zero point 0.05 mm. Okay. So
Mhm.
after selecting the mesh, we create named selection in order to clear our concept that like what will be the inlet, outlet, and wall. So this is the inlet, this is the outlet, and this is the wall. Okay. After doing all
Yes.
this, we just right click here and press generate mesh or update mesh, and this will be done. this process will be done. Okay.
Yes.
So after doing the mesh, our main thing is the setup. This is the main thing of the simulation. Okay,
Mm.
let me start this and show you the steps.
But all this is taking place in Analysis, correct?
Yeah,
Not
yeah.
Fluent, or is it one program?
Uh, all this is in ANSYS Fluent.
Ah, okay.
Yeah. To do these analysis, there are other options as well, like wait, sorry, like the CFX. People also use Fluid Flow CFX, but we use
Mm.
Fluid Flow Fluent.
Because it's the
Because
best for our project.
this is also best, and I also know Fluent. I don't know many things about CFX.
Yeah, okay.
Okay, so after starting the model, like what is the first of all step? So in general, our simulation is a steady state simulation. Like the answers consider that this simulation is running for a quite long time. Till that time, the solution is converged. Like the value by the solution convergence, we mean that the values are not changing, right? So, if you want to do transient analysis, you can also do by checking this, but this will tell you like these analyses are too much long. Like you can't obtain results after 5 seconds or 10 seconds. You have to run the simulation for long hours to obtain the results. And the settings for this analysis is also different. Okay,
I
so
got it.
models. So first of all, we have selected model by double clicking on the model. We have multi-phase, like we are going to use the air as well as liquid. So we have two different substances. So that's why we have chosen mixture here. Otherwise, it would be off. And in the formulation, we have used implicit formulations. There is a specific reason behind it. I will send it to you in the chat that why I chose implicit formulation. Okay. So the second step is energy equation. So when we are going to do simple CFD analysis like computational fluid dynamics, like the water is flowing inside the pipe, and we are only considering like what is the velocity, what is the pressure, then this energy equation is turned off. But when we are going to use like what is the temperature difference occurring in the model and what will be the phase change, then we turn it on. The energy equation, we turn it on, right? After
Okay.
that, the viscous. So if our flow is like laminar flow, then we are going to choose this model, laminar model. But when
Turbulent.
our flow is turbulent, then we can select. We have two options: K epsilon model and K omega model here. So the reason why I choose, if somebody asks why you choose K epsilon model, so as we know that our flow is inside a structure, like there is a room or there is a box and air is flowing inside it. For that, K epsilon model is more suited for calculations. But if your flow is like the air is flowing over a car or over a wings airplane, then we are going to use K omega model, right?
So we used K epsilon.
Yeah, V K epsilon because our flow is inside.
And
Not
because we will use epsilon, K epsilon and K omega if it's turbulent flow.
no no both are turbulent. Both are turbulent.
Yes, yes, yes.
But
I got
if Like if the water is flowing inside the pipe, then K epsilon model is more good for it. But
I get it.
if something is flowing over the body, not inside the body, then K omega is good.
Okay.
Yeah. So after doing these all calculations and wait, yeah, here is the material. I took the material as a water vapor and air which is coming inside, and then the boundary conditions like what will be the inlet, outlet. These are just simple steps. And in the main thing, what is methods? So these are different schemes. Like do you guys have studied the numerical analysis subject in your engineering?
Yes, but it was theoretical,
Yeah,
computational mechanics.
yeah. It was theoretical. Like, do you have studied the Ranjikuta method and something like that? Like, if you want to,
Oh,
if you
mhm.
don't have the differential equation, right? If you don't know the
Yes,
equation of the solution, then you apply numerical techniques in order
exactly.
to come close to the solution.
Yes.
For
By
that
having many
purpose,
nodes,
yeah.
yes,
So similarly, ANSYS is using these these formulations on the back end. So
yes,
based on
understand.
yeah, so there are different models. So just by doing little, I don't have too much knowledge about these schemes, like what is the meaning of simple, what is the meaning of simple C. But in literature review and many videos, people prefer using coupled model and second square of it for momentum, for volume fraction, for all these things. So I just, based on the literature review, I just copy it. Okay.
Okay,
So initialization. So we just hybrid initialization means like whatever software wants by itself. We just do it hybrid initialization like uh, from where our equation should start for in order to get the solution. So this is initialization mean it is just the initial points from where we start our calculation. So if I click on a standard initialization and compute from inlet, so I will ask software that start calculating my values from the inlet. But instead of doing that, I just select hybrid initialization and I let the software to choose the values by itself. I didn't give it. Okay.
okay.
So the last step is run calculations. I just run the 100 iterations, calculate, and in the monitors, you can see the residuals. Wait, I think I have opened that in setups, so it will not open. But our residual graph was just a straight line. So it means by residuals, we mean that if our residuals are in a straight line, it means that our solution has been converged and there are no errors in our solution. So after doing all these calculations, we come to post processing. Wait, let me actually I have opened the setup, that's why. Let's see if it opens. Okay, that's working.
So we started by making the model in SolidWorks, then importing the model into Ansys,
Yeah,
set up and then solution, and then we came up with this result.
yeah. First of all, after importing the model, first of all mesh, then doing the setup, starting the simulation, and after that, these are the result in post processing. Like what are the result after processing?
Clear.
So I also posted these results in your report.
Yes, I read.
So these are just velocity contours. Like what should I explain to you? Like volume rendering, you can get this from here. I have also showed that in video. So like this is the volume fraction of phase one. Phase one was liquid. So this just show you small fractions, like if in the portion where it is red,
The
small
volume is
reds.
high.
Yeah. So it means there are some water vapor, there is more water here near the wall. But here it
Yes.
is green, so the values is also less, and so on. So this
But
is the
how can we read the numbers 1.352 e to the power minus 15?
yeah, these are very small numbers. So this simulation was just for demonstration purpose and learning purpose. So the idea is good, but the results are very small. So this is the main thing in the simulation. If you have any questions, you can ask me.
For me, it's clear until now.
Okay, so this is just the whole idea and everything, nothing else.
Oh, right. I have a question
Yeah, yeah,
regarding the green stuff. You said the green stuff, it means there's less water, and near
yeah,
the surface there is a bit of water where the
yeah,
red color inclines.
yeah, yeah.
All right. For myself, I want you to only explain in details every other pictures that you have put in the results.
Okay,
So if you could do that, I'll be thankful.
yeah, yeah, sure. So, so this is the, like I have added the from location, I have added the plane here in the mid body, and in the contours, this is the velocity contours, like what is the velocity throughout this portion, right? So if you see the green region, like you can estimate the value of velocity is around 2.23. And similarly, if you want to see the pressure, so you can select the pressure from here. Wait, give me a while. I don't know why it is not showing now. So it shows this contours to me for this, but wait, like by changing these values you can get, but the exact, I have made some changes in the simulation. Before delivering the lectures, I was just looking. So as I opened the setup from here, I would have opened this from solution. So there are some changes. So that's why this is showing me different results. But from here, you can select different things, what results you want. And I have also explained these in the report. You can read it, just there will be different colors. Like, let me show you here. Like this is for temperature. Here our temperature is 35 Kelvin, but in the blue regions the temperature is around 300 Kelvin. Here is 350 Kelvin. And where is the pressure value? This is velocity, volume fraction. So I didn't calculate the results because for the pressure we didn't need it, but the temperature contours, the volume fraction are here. Let me open this pane and see the temperature as well. So brother, I have made some changes in the calculation. That's why it is showing different results now, but the main results are here. It is shown. If you need any explanation in these results, I can explain it to you.
Can you tell me why in the top of the cube there is different colors? It means there's different temperature
Wait,
for the
let
one
me
below.
open here. You are talking about this image?
No, I'm talking about the down two images.
Wait, this one. This image. Hello, can you hear me?
Yes, I can
Yeah,
hear
I
you. Maybe.
can hear you.
Yeah, so in the temperature, like you want to ask me that why this portion is red?
No, just not why. Explain. Is it because of the inlet and the outlet and just simple stuff like this?
Yeah. So in inlet, when the air was coming inside, so its temperature was around 350 Kelvin. 3.5 raised to power 2 makes 350 kelvins, right? So after inlet, it comes in interaction with the valves and the temperature keeps decreasing. So this is like the temperature gradient and here this portion, the light blue portion shows that the temperature from 350 came down to 314, and then at the outlet, the temperature was minimum with the value of 299 Kelvin.
Mm,
So
all right.
yes. So this is the whole thing. When you guys have presentation?
But
Tuesday.
there is something else I told you about in the voice note, if I may ask you,
Yeah.
about some scientific ideas which you added, K epsilon and K omega, because the doctor
Okay.
told us that we may face a lot of questions about it. Also, you added some equations in the beginning of the simulation.
Yeah.
Uh, so would you please just give some little explanation in that side?
You are talking about these equations.
Yes, that's section.
Okay. Basically, I also don't have too much exact knowledge about these equations, but I can
In
explain
general.
you a little bit. Like the
No problem.
Navier-Stokes equation, like if the fluid is going inside the pipe and you want to know about the value of pressure or value of temperature or the discharge, like what is the flow rate at
Mhm.
at a certain point, you can use continuity equation, you can use Bernoulli equation, right?
Yes, that in fluid
So,
dynamics.
but if it is very complex, then we couldn't find the exact solution, right? So for
Yes.
that, we have Navier-Stokes equation. So this Navier-Stokes equation is like numerical approach in order to find the approximate value of the solution, Navier-Stokes equation. So no one in the world has find out the exact solution of by using this equation, Navier-Stokes. But we approximate our results. So for that, Navier-Stokes equations has three portions. Continuity equation in which he has mass conservation and then momentum conservation. Like he says, like the basic idea of mass conservation is like what is coming inside the body will be equal to what is going outside the body and what will remain inside the body. So this is mass conservation. Momentum conservation is mostly related to the energy. So he considered this, and the third one is energy conservation. So these are
So,
the main
hmm.
three equations. These are differential equations. So this is whole different field. I don't have too much knowledge about this, but in your presentation you can just say that in the back end of ANSYS simulation in the back end, what is going to run? The ANSYS is running Navier-Stokes equation to solve the problem.
So it's just an alternative for the continuous equation and Bernoulli equation because it is complex. So this
Yeah,
one is more helpful to get closer solution.
exactly.
Uh,
These are basically
okay.
numerical schemes, not
Yes,
exact
yes.
schemes of the equation. So, moreover, phase change model, I have already explained that when we are going to use two different fluids and we want a phase change, then we will also take the effect of this thing and so on. If you
And
can just
yes,
just write this and Google it or just
to have
make some
more
searches, you can
information.
get more good and clear idea about this.
Uh, and also you mentioned some information about K epsilon and omega epsilon. So would
Yeah,
you just give some little general explanation on that side?
like wait, let me read that again and give it back to you. So, brother, the main idea between this is just the turbulent model. Okay,
Yeah, yeah, as you mentioned
in
before.
turbulent,
Yes.
yeah, I mentioned before. So in this, it consider two factors: turbulent kinetic energy and turbulent dissipation rate.
Mhm.
Like what are the losses inside and what is the kinetic energy? Represents the strength of turbulence in the flow by tracking the energy associated with turbulent fluctuation, whereas the epsilon equation determines the rate at which turbulence dissipates. Like K epsilon, in which K means what is the kinetic energy of the body, and epsilon means dissipation rate, like at how much rate the energy is dissipates, like the energy is losing. So this is the meaning of K and epsilon. Yes, which is aerodynamic. Okay, brother. So if somebody asks you, please explain K epsilon model. So you just have to say that, this is our two equation model in which the first equation K is considering the effect of kinetic energy in a flow. And the second part of the K epsilon model is epsilon, in which we are just considering the turbulent dissipation, like at how much rate we are losing our energy in a system. So just say this, and I hope your professors will be satisfied.
Okay, for
Yeah.
me, I think everything is clear, but I don't know if someone has a question.
One thing I want extra information about is the figures 24 to 26, where you have the graph. I just want to
Yeah.
understand more about it.
Yeah. So brother, these graphs like show here, this is the velocity in the x direction, and here is the distance. Like from the inlet, our velocity is going to decrease, and this is decreasing up to 0. And similarly, in the temperature, this
One question. It's decreasing towards the outlet.
yeah, it is decreasing towards the outlet.
All right.
Yeah, and this is very this is also very confusing, the temperature. So because this is the mixture of airs and vapor and some liquid, that's why ANSYS is just giving us these value. But it shows us as in the contours, it was showing us the value. So here you can see the maximum and minimum value at this distance in the y direction. And similarly, this is the pressure. The pressure was initially low and then it decreases.
But how can pressure decreases from 0 to minus? That means there is any low pressure inside of our cube, or what does that mean?
No. These values are not exactly like 0, but in graph, we are getting these results. So when the air comes from the inlet, it has more pressure. But as we go away from the inlet, the value kept on decreasing.
Oh, okay, now I understand.
Yeah. So is it good?
Yes, thank you.
Welcome.
One extra thing, there is figure 27 and 28 and 29.
Yeah.
Is it the same figures from before? But this has a different
No.
texture or different picture.
These figures have the same meaning, but these are
The pressure
isosurfaces.
contour.
Yeah, these are isosurface. Hello, can you hear
What's
me?
the surface?
Yes.
Yeah, we can hear you.
These when you read this graph, these graphs have the same meaning, but these are not contours. These are the isosurface. Contours just give us the values on points. This is the whole surface which ANSYS is showing us.
So this is in surface, but the previous one in points.
Yeah, those were just contours, and these are surfaces. They have same meanings, but just showing us the values on the surface, the whole surface. Previously in the ANSYS, I just choose the plane in order to
Yes.
get to those points. But this is the whole surface.
And also for the points, it's only showing the middle point. It's not showing to the far right or the far left.
Yeah,
Is it not necessary?
that was the plane on the exactly on the center of the body.
Is it not necessary to show other points
You
just
can
like
show it.
the volume factor.
You can show it just like this is the plane. Wait, why it is not working? My laptop is actually very slow. Like this is the plane, right? So
Yes.
I can change the location of my plane. Wait, like if I want to change the location of my plane, I just change its value from here, apply, the plane will move right or the plane will move left, and then we can select our value. So if you, these are not necessary, but if you still want, I will add these values as well. But some of these results are shown in the isosurface. So I think this is not necessary, like adding the plane on any other different location, right?
Hello.
Hello.
Yes.
Yes.
I have a
So
question about the boundary setting up.
sorry.
I have a question about the boundary. So we have an
Yes.
inlet and outlet in the wall.
Yeah.
What about the rest of the geometry? Do we have to like name things or?
What do you want to? Sorry, what I didn't get your
Okay,
question.
we have a question about the boundary setting up.
Yeah.
Okay, we have an inlet and outlet, and we have the wall.
Yeah.
What about the rest of the geometry? Is it like already setting up or?
Yeah. Yeah. I just name it. I just name three things: inlet, outlet, and the wall. The rest is the whole body. The rest which I didn't give it a name. The ANSYS took it a body, the whole body by itself.
Okay.
I just gave the name of the things which I wanted. The rest of the body is also considered as a wall, but with a different name, body.
Yeah. Okay. Clear.
So yeah, that's why we don't need to name each and everything. We name the things which we need only. So everything good?
Yes.
Okay, brother. So I think we should end the meeting now.
Thanks a lot for your time. But would you please send the recording after you finish?
Of course. I will send it.
Okay. Thank you.
Welcome.